Hey everyone, it's Dr. Newell, and we are dividing whole numbers by fractions. And I want to make sure, as always, whenever I can, I want to give you some models or sketches to help you figure that out. And then we'll move on to what is traditionally done in math that I don't necessarily care for, but it does happen sometimes. All right. So I want to go this route first because I want you to understand what's happening when we divide a whole number by a fraction or even when we divide a fraction by a fraction. So, for example, I have a whole number here. That whole number is 2. I want to know if I have 2 of something, how many groups of 1/2 can I come up with? That is what this division means. Okay. When I have 2 of something, how many 1/2s or how many groups of 1/2 can I find within that 2? All right. So I'm going to show you with a model. So I'm going to draw out my 2. This is my 2 wholes, and I am going to make some halves. All right. And I need to cut them into 2 parts because that's what the denominator says. All right. But I am not just looking for, I'm not looking to shade things in. I'm looking to number them. So I have 1/2 right here. I have another half right here. I have another half right here. I have another half right here. So how many halves are in 2? Well, if you said there are 4 1/2s in 2, you are correct. And this makes sense because there are 2 halves in 1 whole. All right. So now I hope you understand what it means when we are dividing by a fraction. Let's go ahead and look at our next problem. Our next problem here is, okay, I've got 3 and I need to know how many thirds, I'm sorry, how many 3/5 are in maybe let me do something different here. I'm gonna have 3 and I want to know how many 1/5 are in 3. So I'm gonna go ahead and make 3. And now I'm gonna divide this up because our partitions need to make us have 5 parts. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. How many 1/5s? How many 1/5s can I have in 3? Well, that's an easy one. This is 1/5, right? So empty, all of these parts are 1/5. We get that, right? So let me go ahead then and just let's count out how many 1/5s we can have. 1. Okay, I erased my line there, so I can have 1, 2, 3, 4, 5, and 5 times 3 is 15 because each one of these has 5 in it, right? So that'll be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if somebody said to me, Dr. Noel, how many 1/5s are there in 3 wholes? I would say there are 15 1/5s in 3 wholes because I can divide each of the 3 into fifths, and then for each part, that's 1/5. And if there are 3 of them divided into fives, then that's going to be 15 because 3 times 5 is 15. Are we good here? If we're good here, we're going to press on. If we're not, I want you to pause and go back because now we're getting ready to do something different. All right. Now I'm going to go and I'm going to just start with a smaller number. And I'm going to say if I had 2 of something and I needed to find out how many, um, if I could break it into thirds, and we already know if I do 2 and I'm going to do thirds, I only want 1/3. I want to know how many groups of 1/3 can I find in there. So that means I need to divide these up into how many parts? If you said 3, you're a genius. And this is a third, right? Is this a third? All of these are thirds. So how many thirds do I have here? I have 3. And I made too many. Why did y'all tell me I made too many? So I've got 2 wholes that are going to be broken into thirds, right? All of these individual parts are 1/3. So how many 1/3s do I have in 2? Again, there are 6 1/3s in 2. Excellent. Let's move on and let's make this 2/3. That's what we're going to do. We're going to make it 2/3 now. So now if I had 6 1/3s, if I could pull out 6 groups of 1/3s, how many groups of 2/3s can I pull from 2? Let me just go ahead and erase what I wrote in here. Let's erase that. Because now I'm looking for something different. I'm looking for 2/3. Okay? 2/3. So let me write that in. I've got 1/3, 2/3. So that is one group of 2/3. Got it? Let's move on. Now I've got another 1/3, and this 1/3 combined makes another 2/3. Excellent. Now I've got another 1/3 and another 1/3. How many groups of 2/3? I'm sorry, 1/3 and 2/3. How many groups of 2/3 do I have in 2? I have 3 groups of 2/3 in 2. I only have 2 wholes, but I need to figure out how many 2/3 I can pull out of that 2 hole. Oh, you can pull 3. Let me tell you when this is important. Let's say I had 2 candy bars and I needed to know if I had them broken into thirds and they were supposed to be shared in 2/3, how many people would be able to eat that candy bar from those 2 candy bars? That's why this is important. Because sometimes you need to break stuff down like that. So this would be me, this would be Samantha, and this would be Anthony. So me, Samantha, and Anthony, we can eat from this candy bar. The rest of y'all can't have none. Because I needed to give them away in sizes of 2/3, and I only had 2 candy bars. Now we could make this a full-on math problem for our class and say, well, if I know that 2 candy bars at 2/3 a portion per student would feed 3 students, how many candy bars would I need to feed 34? Oh, but we're not going to do that right now. If you want to do that challenge, you go ahead. I'm not going to, because I can hear some of y'all say, Doc, that ain't even part of this problem. All right, so let's get back to it. We had 2 divided by 2/3. Now, let's do a different problem. And then I want you to pause the video and try to do what we just did and solve it for yourself. So now we're going to do 3, if I can remember to put my pen back on, 3 divided by 2/5. What does that mean? 3 divided by 2/5 means I have 3 holes, right? 3 holes, and I need to figure out how many groups of 2/5 can I get out of those 3 holes. Okay. Another way to do this would be able to figure out how many 2/5 is in one hole and then just multiply that by 3, obviously, right? So how do I divide this hole? I'm going to divide it up into fifths, which means I need 4 partitions. And now that this is divided into fifths, I'm going to go ahead and do my 1, 2, 1, 2. So here is a 2/5. Let's go on to our next color. Here's another 2/5. Let's go on to our next color. Here's another 2/5. Here's another 2/5. Here's another 2/5. I'm trying to get some colors that aren't so close because I don't want to get confused later. That's going to confuse me. Let me do something different here. I'll make that black. All right. So now how many 2/5 was I able to find? I have 1, 2, 3, 4, 5, 6, 7. So I was able to find 7 groups of 2/5. And then what did I have left over? I had 1 piece left over. But how did they need to come? They needed to come in 2s, right? So that becomes my denominator because I have 7 and 1 piece left of the 2. Right? This part is different from what we've been doing because we haven't had any leftovers. We've been filling it out. But in this one, I see that when I have 3 holes and I need to figure out how many groups of 2/5 are there, I'm going to have 7 groups of 2/5, but there's going to be this 1, that doesn't quite have a full group. And so that's going to be 7.5. Now, right here, I want you to pause and think about it, go back over it, figure out what you can figure out. But I want to also show you what people traditionally do. And I don't like it, but it's what people do. And it makes it easier on them. I just need you to know what division of a when you have a whole number and you're dividing it by a fraction, I want you to know what that really means. And this right here is what it really means. I need groups of 2/5 in 3. I need to figure out how many groups of 2/5 I can get out of 3. Okay, because I've got 3 whole candy bars, and if they are portioned off in 2/5, how many students can I feed? Well, I can feed at least 7, and then there's going to be one who might get half of that fifth. So they may get 1/5, right? All right, so let's do what people commonly do. And some of y'all gonna say, Doc, why didn't you just show me this? Because I need you to have a better understanding of what we're doing when we're mathing. I don't need you keep flipping, changing, and you don't even know what's going on. All right. So another strategy that you may see people use is what they call keep, flip, change. KFC, chicken, right? And so what they do is they keep the dividend, which is 3, because this is what's being divided. They change that sign of division to multiplication, and they invert. They change the sign and they flip. Keep, flip, change the divisor. Okay. And when they do that, now they multiply across. Now they're back to multiplying fractions. Some of y'all said, I already knew how to do that. That's good. But did you understand what you were doing? That's what's most important. So now I've got 15 and I've got 2. And we all know that we must simplify this. This is an improper fraction. We need to at least make a mixed fraction. So if I've got 15 over 2, remember our fraction bar says divide. How many 2's are in 15? There are 7, because 7 times 2 is 14. How many is left over? 1. And what was my denominator? 2. 7.5. Same thing we just did. All right. I wanted to show you the model because I need you to understand how to figure out how many groups of something are within something else. All right. There are so many other ways we could have done this. So many other ways. And as we get into working problem strings and things like that, you will see that there are other ways. We can always use what we know. There's just so much, but I want to also show you, because I believe our textbook shows you this keep, flip, change thing, or keep, change, flip, however they say it. But that's what they're showing you to do. And I want you to be able to work on the problems in the book as well. But I want you to have a good understanding. All right. So that is it for dividing whole numbers by fractions.